Welcome to the Electrical and Electronic Engineering Lecture Series. Your anchor person is Professor Michael C. Ndinechi. Our topic today is Types and Structure of General Purpose Computers, Part 4. Please follow me in this lecture series by subscribing to my YouTube channel at https://youtube.com/@NdinechiMichaelC. Like, share, and drop your comments in the comment section or reach out to me using my email addresses. You can listen to my introductory lecture on computers at Module 6 using the YouTube link. You can also listen to Module 014, Part 1, 2, and 3 for better understanding of this Part 4. So let's quickly recall that in our Module 006, we differentiated between a computing machine and a computer system. We said that a computing system requires the addition of software to be at its premium optimum performance. For a computer to work effectively, three things must be present. The first one, the physical computer must be there. The second one, there must be the presence of a software that will make the computer to execute the function that is required of it. And thirdly, somebody has to issue the command to the computer. We say that this is analogous to a car. The physical car has to be there. For the car to move, there must be fuel, petrol or gas, or presence of electricity for an electrically operated car. And lastly, somebody has to be there to maneuver the car either remotely for driverless cars or locally. The first, which we call the physical car in the computer parlance, is known as the hardware. The second, which we call the software, is something like the fuel, and the third, known as the peopleware or the professionals. This we have illustrated in Module 014, Part 2. So let's quickly look at the hardware. Hardware is used to describe any component or units used in the construction of a digital computer system that we can see, we can touch, like the input devices, the microprocessor chips, the memory chips, the input and output chips, the auxiliary stores, and other output devices. The software is the general term used to denote all forms of program associated with computing system. The term software is often used to include not only the programs, but any documentation associated with the computer, documentations like manuals, circuit diagrams, compilers, assemblers, and so on. Therefore, a program is any list of instructions or routines or actions set out in a logical order to solve a particular problem. All digital computers, as we know, work on sequential basis. In our later topics, we'll be looking at how these computers combine combinatorial and sequential logic to operate. Each instruction given to the computer is carried out one by one until all the instructions making up the program have been executed. Therefore, a programming language is a language for instructing the computer. And at this point, we ask you to drop at least 3 programming languages you know in the comment section. A complete program in any language is often referred to as the code, and the programmer is sometimes referred to as the coder. Different levels of software exist, as we can see. The first one, not in any order, is the utility software. Utility software is designed to do special operations such as data backup, virus detection and cleaning, disk repairs, and data recovery from a bad sector of hard disk drive, and so on and so forth. So we also quickly ask, name 3 utility software you know or you have come across in the comment section. The next type of software is the ones known as the assembly language software. So this type of software utilizes mnemonics or mnemonic instructions or abbreviations to represent instructions. It normally has an operation code, otherwise known as the opcode, which is the instructional part, and an operand, that is the data to be acted on. They are also known as machine languages. Different microprocessors, as we have seen in past topics, have different instruction sets from which these assembly language codes may be written. There are special programs called the assemblers, which are designed to reduce the number of the bits required to instruct a computer. In other words, the assemblers helps the system to reduce the number of instruction sets that a computer can use to carry out any instruction. When this is done, it may be used to build other hardware called the firmware. We have already met this firmware in our previous lectures, but let us recap that firmware is the term used to describe those programs which are permanently stored in the central processing unit, the CPU, and are necessary for the control of the computer at the time of startup, shutdown, carrying out input-output procedures, and so on in the computer. These firmware programs are born into the read-only memory section of the central store, usually at the time of manufacture, and cannot be altered. The assembly language software enables the programmer to instruct the constituent components of the computer directly. The next level of software is called the high-level language. So these are languages. It could be English language, it could be any other language. The high-level languages are language-based procedures and are much easier to deal with than the assembly languages. It uses more familiar notation and language words, and one instruction equals many assembler or machine instructions. Computers find it easier to read long strings of ones and zeros. That is why they are called digital systems. But reading meaning into this string of ones and zeros is difficult for human beings. Therefore, programmers have translated machine language into the so-called high-level languages, where high in this sense means more like natural language. So no matter the language you speak, programmers have translated machine languages into your language. High-level language programs are usually translated into machine language instructions by a compiler. The compiler translates each statement of the high-level language into its equivalent set of machine instructions. The compiler is also responsible for keeping track of instructions and data locations in the memory. The statements of the high-level languages are called source codes. Examples of high-level languages include programs like BASIC, Beginner's All-Purpose Symbolic Instruction Code, COBOL, Common Business Oriented Language, Fortran, Formula Translator Oriented Language. Also have the C and C++ language, Visual Basic, Lisp, Java, and debuggers. So join us in Module 00014 Part 5 so that we look at the remaining aspects of the general purpose computers. Thank you for listening.